Welcome to another lesson of our AI governance course. Today we dive into another important fundamental topic, the ecosystem of participants in AI projects and the organization of their effective collaboration. We will learn how to identify the key participants in the ecosystem and define their roles and analyze the interests and potential conflicts among different stakeholder groups. This lesson will lay the foundation for understanding the complex network of interactions in AI projects and will prepare us for the next lesson, where we will move from a static map of roles to the dynamics of processes and the distribution of responsibility. And, of course, we will apply the knowledge gained in practice when populating our AI system passport. As always, I'll ask you to like this video and subscribe to the channel if you enjoy our educational materials and do not want to miss new lessons. Now, let's get started. Let's imagine the participants of an AI system as a symphony orchestra like in this amusing AI-generated image. Each musician has their own part, instrument, and role in creating the overall sound. The conductor coordinates all the parts, but the success of the concert depends on the seamless collaboration of all participants, including the audience. However, unlike an orchestra that plays a single piece, in an AI project, each stakeholder group may have its own, sometimes conflicting goals. Our task as AI governance professionals is not only to have a detailed understanding of the rights and obligations of all stakeholders but also to understand their goals and interests and be able to harmonize them. To effectively manage this complex orchestra, we need a professional tool to visualize all its participants. It is called a stakeholder map. In front of you is a universal template of such a map, showing the key participants of a typical AI project. In this lesson, we will study each role on this diagram in detail. In the next practical session, you will apply this knowledge to create a stakeholder map for a real-world case. This map will become another important section in our AI system passport. Before you is the complete ecosystem of participants in a modern AI system. It is divided into two large domains: internal, those inside your organization, and external, everyone who interacts with the system from the outside. On the left, inside the company, we see four key functional blocks. These are the technical teams that directly develop the technology. The business side, from senior leadership to internal users. The IT and infrastructure teams that ensure the solution's reliability and security. And finally, a critical block, governance and compliance. Our legal, ethics, and compliance specialists who ensure adherence to established rules. Now let's look to the right, at the external world, which has a huge influence on the project. First and foremost, our end users. Then there are regulators, the government bodies that establish laws. There is a whole ecosystem of partners and suppliers on whom our project depends. And finally, society and the market as a whole, investors, human rights organizations, and the media, which shape public opinion. This map is our guide for this lesson. In the following sections, we will dive deeper into each of these roles to understand their goals, interests, and areas of responsibility. Let's start with the internal stakeholders. Internal stakeholders are the participants within an organization who are directly involved in the life cycle of the AI system. They can be classified by functional areas: technical, business, supporting, and oversight roles. Let's consider each of these functional areas separately. Technical roles and their responsibilities. Let's begin with data scientists. These are the researchers who test the hypothesis that a business problem can be solved using data and machine learning. They find patterns in data and create experimental model prototypes. Core responsibilities usually include research functions, such as conducting exploratory data analysis, identifying patterns, and formulating hypotheses. Modeling, which involves developing experimental prototypes, selecting appropriate algorithms, and feature engineering. Validation, which is developing a methodology for evaluating model quality, running experiments, and analyzing errors and limitations. And finally, communicating results, preparing reports, visualizing findings, and explaining technical decisions in a way that is understandable to the business. At this stage, the foundation of the future system is laid, and with it, its fundamental risks. The choice of data determines the model's potential bias. The choice of validation metrics defines what the system will consider a success. Our task is to ensure that at this early research stage, all issues of ethics, fairness, and alignment with business objectives are considered. Machine learning engineers transform an experimental model prototype into a reliable and efficient software product ready for production environments. They are responsible for the quality, performance, and testability of the model's code and its associated processes. Their core responsibilities include adapting code for production, which means converting research code into optimized, testable, and maintainable code. Building data pipelines by designing and implementing the logic for automated data processing workflows. Model deployment, which is packaging the model as a service, for example, by creating an API. And model-level monitoring, which involves developing specific metrics to track the quality of model predictions. Understanding these tasks is critical because it is at this stage that the model's theoretical risks become real. A bug in the production code can distort the model's logic. A poorly designed API can become an attack surface. A lack of quality testing will lead to failures in production. The AI governance specialist must ensure that standards, checklists, and quality assurance procedures are in place for all these tasks. The product owner is the voice of the business and the user on the technical team. They define what the AI system should do and prioritize tasks to maximize value. Core responsibilities include strategic planning, such as defining the long-term vision for the AI product and creating a roadmap. Requirements management, which involves collecting and analyzing user needs and translating business tasks into technical requirements. And coordinating development by planning sprints and making decisions about trade-offs. The product owner makes key decisions about these trade-offs. For example, should we sacrifice some accuracy for greater model explainability? Or delay the launch for an additional ethics audit? Our task is to provide the product owner with the information and tools to make such decisions based not only on business metrics but also with full consideration of risks and ethical principles. Now let's consider the stakeholders from the business side. We will, of course, start with senior leadership, which defines the strategic importance of artificial intelligence for the company and allocates resources. It bears the ultimate responsibility for the financial, reputational, and legal consequences of AI implementation. Their primary interests include return on investment, competitive advantages, and managing strategic risks. Without the support of senior leadership, any AI governance initiative is doomed to fail. Their tone from the top determines whether responsible AI development becomes a real priority. Our task is to convey to leadership that a robust AI governance system is not a hindrance but a necessary condition for achieving a sustainable ROI and minimizing strategic risks. The category of functional leaders includes heads of departments who are the primary customers and beneficiaries of AI systems. They define the specific business problems that AI is meant to solve. Functional leaders understand the application context of artificial intelligence better than anyone. They know where the system might fail in the real world and what the consequences would be. Their involvement in the risk assessment process and in defining the criteria for acceptable system performance is absolutely essential. Another key business stakeholder group is internal users, the employees. They are the direct users of AI tools in their day-to-day work. The system's real-world value depends on their adoption, trust, and feedback. Their main interests include the tool's efficiency and ease of use, trust and understanding of the product, and a sense of safety and confidence. Ignoring internal users is a common reason for the failure of AI projects. A system may be technically perfect, but if employees do not trust it or use it incorrectly, the entire investment is wasted. AI governance therefore includes user training, creating clear instructions, and establishing channels for collecting feedback. The next key area of internal participants in the AI ecosystem is IT teams, responsible for infrastructure and support. MLOps and DevOps engineers develop and maintain the automated platform for the entire AI system lifecycle. The key objectives of their work are to ensure the reliability, scalability, and reproducibility of all development and operational processes. Their primary responsibilities include managing and automating machine learning pipelines, implementing an infrastructure as code approach, automating continuous integration and deployment processes, and monitoring the system state, including tracking shifts in data's statistical properties, known as data drift. The effectiveness of an AI system is not static, it can degrade over time. MLOps practices create the technical foundation for managing this degradation. Automated monitoring of data drift serves as an early warning mechanism for when model performance is deteriorating. The reproducibility of pipelines is a prerequisite for conducting audits and incident investigations. Therefore, the absence of mature MLOps practices makes responsible AI operations impossible. Security specialists protect all components of the AI system, data, models, and infrastructure, from external and internal threats. Vulnerabilities in AI systems can lead not just to data leaks, but to the manipulation of the system's decisions, which can have catastrophic consequences. Our task is to integrate the assessment of these unique attack vectors into the overall risk management framework. And the last functional segment of internal AI system participants is governance and compliance roles. Let's consider our own role as AI governance specialists. In modern companies, this is a central, coordinating role for AI governance processes. The AI governance specialist develops and implements the rules of the game, ensuring that the development and use of AI within the company are responsible, transparent, and compliant with laws and ethical norms. Core responsibilities include developing and implementing internal AI governance documents and standards, coordinating stakeholders and resolving conflicts, managing AI risk assessment processes, and conducting monitoring and reporting. This role connects all other participants, ensuring that governance processes do not just exist on paper but are embedded into the real development and operational lifecycle of AI systems. Often, AI governance specialists also perform the function of an AI ethics officer. In some teams, this is a separate role. This role helps the team identify and mitigate potential negative social and ethical harm from the AI system. Key objectives include minimizing social and ethical harm, ensuring the system aligns with moral and cultural norms, and fostering long-term user trust. Laws and regulations always lag slightly behind technology. The ethics specialist helps the company act not only within the law but also within accepted moral norms, thereby protecting the company's reputation and building user trust for the long term. And the final internal role is the compliance and legal teams. These teams ensure that the AI system does not violate applicable laws and regulations. They translate legal language into technical and business requirements. Their primary responsibilities include ensuring the company's legal resilience, reducing the risk of fines and sanctions, and supporting a safe go-to-market for the product. Violating laws related to AI and data can lead to enormous fines and a complete ban on a product's use. Legal, compliance, and data protection specialists are the company's first line of defense against legal risks. Their sign-off is mandatory before any AI system can be released. Now let's move to the other side, the external stakeholders of our product. They represent participants in the ecosystem who are outside the organization but have a significant influence on the development, implementation, and operation of our AI systems. Their influence can be direct, through regulatory requirements, or indirect, through public opinion and market pressure. Let's start with those for whom every product is created, the end users. They are not a homogeneous group. They can be classified by their level of technical literacy, the degree of voluntariness of their interaction, and their vulnerability. However, what unites them is that they all have fundamental rights that we are obligated to respect. These fundamental rights include the right to be informed. An end user has the right to know when they are interacting with an AI system. The right to an explanation, to receive a clear explanation of the logic behind a significant automated decision that affects them, their rights, and their obligations. The right to object, to request human intervention when a user believes the algorithm has made an incorrect or unfair decision about them. And the right to rectification, they can demand that inaccurate personal information be corrected. Special attention must be paid to protecting vulnerable groups by ensuring simplicity, accessibility, and safeguards against manipulative content. The next important group of external participants influencing any AI system are regulators and supervisory authorities. The global landscape of AI regulation, which we will discuss in detail in future lessons, is rapidly taking shape. At this stage, it is important to understand the general principles that underpin most modern approaches. A risk-based approach is the cornerstone of modern regulation. Systems are classified by their level of potential harm, and the requirements are proportional to that risk. Regardless of the jurisdiction, regulators typically require high-risk systems to demonstrate robustness, have quality management systems in place, and ensure transparency and human oversight. Modern laws introduce liability not only for the developer but for all participants in the supply chain, providers, deployers, and importers. AI regulation is closely intertwined with data protection laws like the GDPR. Understanding these general principles allows you to build internal AI governance processes that can adapt to changing requirements in different countries around the world. Modern AI projects depend on a broad network of partners and suppliers. Data suppliers include commercial vendors, open-source dataset providers, and data-sharing partners. It is crucial to assess the quality and legality of their data collection methods. Technology suppliers include cloud platforms, pre-trained model providers, and hardware manufacturers. Integration partners include system integrators and consultants who help implement AI solutions into business processes. And beyond direct partners, an AI project is influenced by a broader ecosystem of societal and market forces. These include human rights organizations that monitor for discrimination, lobby for regulations, and shape public opinion. They can be valuable partners or powerful critics. Professional associations that create industry standards and ethical codes. Investors and shareholders who focus on long-term sustainability and corporate reputation. And, of course, the media and the general public, who shape the public perception of your product. They can either support a project or sink it. So, we have completed our overview of the ecosystem of participants in an AI project. We have created a detailed map, identifying key internal and external roles. Here are 6 short questions on the material we've covered. Pause the video and try to answer them. If you have any trouble, write your questions in the comments, and we will be sure to respond. The key takeaway from this lesson is this: every AI system exists not in a vacuum, but in a complex network of human and organizational relationships. Understanding the goals, interests, and potential conflicts of each of these groups is the first and absolutely essential step toward building an effective governance system. We have created a static picture, we've identified the who's who. Now, we are ready to move to the next stage, studying the dynamics. In the next lesson, we will explore how to distribute responsibility among all these participants, how to organize their collaboration, and what models of governance and control exist. This will allow us to move